going to solve leetcode problem 3171. This problem is a two-pointer problem actually. So I think let's read the question first, then we can discuss about the solutions together. So we're given an array names and an integer k, and the goal is to find a subarray of names so that the absolute difference between k and the bitwise OR of the subarray elements is as small as possible. So we just need to return the minimum possible value of the absolute difference. So we don't need to provide how to do it, we just provide the difference. So there are three examples, and we will walk through these examples for the example 2, for example. So there are several ways to select the subarray, right? But no matter how you do it, the minimum difference you can get is 1, because it is either you select this one or you select this one, then you get the bitwise OR to be 1, and the difference will be 1 minus 2, then absolute value is 1. And for example, this one you have only one value, so the difference is 9. Okay, so in order to solve this problem, let's first see about the constraints. This names is pretty large, it's 10 to the 5th, so this indicates that we have to use some like linear or some n log n method to solve this problem, otherwise we will break the time constraint. So as I mentioned, this problem can be solved by two-pointer. The main observation is for bitwise OR of multiple numbers, the value can only increase. So for bitwise OR operation, result cannot decrease. Okay, so this is a very important observation here. So we can keep j and I as two pointers pointing on different index in the names. Then we can keep track of names, the bitwise operation from names j to I. So the way to do it is like this. First, we initialize j and I to 0. Then we will add num I into the total value. So we say the total value is just the OR of names from j to I. Okay, then we can update j if value is greater or equal to k, and update I if value is less than k. Okay, then for any update we calculate diff between value and k. Of course, this is an absolute value. And then we can just return the minimum diff. This is the main idea. So in order to do this, we need to have functions to easily calculate the total value between names j to I. Then we can represent any number by a 32-bit vector to represent an integer by 32-bit vector. So we use like a vector of p named p. It has 32 positions initialized at 0 to represent how many 1s on each position. So this actually means P1, if we have Pi equals M, this means at bit I, there are M ones in total. Okay, so then we need some function to get the integer value from P. So we have this function. This is to get the integer value of P. In order to do this, we will loop over all the position in P if the for this position Pi, the number of 1 is greater than 0, it means the RES this bit can be included in the RES. Okay, then we can RES. Another function we need to implement is to update this vector by some integer. So we need to add the bitwise representation of val into this P. So in order to do this, we still need to loop over all the positions, all the 32 bits. Then if the bit on val is 1, it means we can increase for Pi. So this VAL right shift by I means, for example, VAL is 0, 1, 1, 0, 0, 0, and I is 3. Then VAL right shift by I is just 0, 1, 1, right? And then we add the end1, so this is end1. This will be equal to 1. Okay? So this operation decides whether this bit is 0 or 1. If it is 1, we can add the Pi by 1. So if after we have these two functions, we will just calculate the use the two-pointer method to do the calculation. We have I and j. We keep j always less than 1. That's all equals 1 than 1. Then we loop over all the numbers. First, we do an update. We have update the names I into P. Then remember that we need to update RES. Oh yes, it should be initialized by a max. RES and RES get of P. ABS K minus get P. Okay. Then while j less than I and get P is greater or equal to K, we need to subtract num j from P. In order to do this, we'll loop over all the positions, all the 32 bits, and if nums j on that position, or we have used I before, so we use T here. T. So if nums j on this position is a 1, then we can subtract it from P. Okay, then we can calculate the difference. The difference is the absolute value, and get P minus K, right? And if diff is equal to 0, we just return 0. Otherwise, we update RES. Okay, then we update J. And finally, we just return RES. Let's see how things going. we have something wrong here. Okay, so get P, ABS, and another one. Yeah. Okay, it seems it passed. Let's submit. Yeah, all passed. I think the main idea here is to use a two-pointer method because this result cannot decrease. And similar idea can be used to, like, if they are asked, well, how about the bitwise AND operation? Then we can use a similar idea because the bitwise AND operation will never increase. Okay, so that's it for this question. And thank you, and see you next time.